Hello everyone. I am Shobhitaa Barik and I'm pursuing computer science engineering at Bennett University and I'm currently in my third year right now. In this video, I will be covering the topic of iris scanning as an assignment for my course Seminar on Special Topics in Emerging Areas. Before I start this topic, I would like to say a few words about Bennett University. Bennett University is a private university in Uttar Pradesh with the aim of providing Ivy League quality education to undergraduate and postgraduate students in various fields like engineering, management, law, media, and liberal arts. Located at Greater Noida, Bennett was founded in 2016 by Times of India Group. In this video, I will be covering what is an iris and what is iris scanning, followed by its history and how iris scanning or recognition works. I will also cover the advantages and disadvantages, as well as the applications of iris scanning. We will be seeing the differences between iris scanning and retina scanning, and the future scope as well. So, what exactly is an iris? The iris is the colored donut shaped portion of the eye behind the cornea and it surrounds the pupil. Pupil is the black colored part of our eyes which is behind the iris and it helps us to fit the focal length of our eyes. The cornea is your eye's clear protective outer layer. It serves as a barrier against dirt, germs, and other things that can cause damage. Since the iris is covered by the cornea, it is well protected from damage, making it a suitable body part for biometric authentication. A person's iris pattern is unique and remains unchanged throughout life, exceptions being the cases of major eye injuries or diseases. It is important to know that the chances of two people having matching irises is practically zero. The irises of identical twins are as different as irises of unrelated people. Artificial duplication of someone's iris pattern is virtually impossible. So, iris scanning or iris recognition is an automated method of biometric identification in which visible and near infrared light is used to take a high contrast photograph of a person's iris for the purpose of identification. Let's take a look at the history of iris scanning before we understand how it works. The idea of using iris patterns for personal identification was originally proposed in 1936 by ophthalmologist Frank Birch. By the 1980s, the idea had appeared in James Bond films, but it still remained as a science fiction. In 1987, Aran Safir and Leonard Flom patented the idea and asked John Dugman to create an actual algorithm for that. John Dugman created this algorithm and patented that in the same year. The algorithm which Dugman developed is the basis for all current iris recognition systems. Dugman's algorithm is owned by Iridian Technologies and the process is licensed to several other companies. One active imaging system developed in 1996 by licensee Sensar deployed special cameras in bank ATMs to capture iris images at a distance of up to 1 meter. This active imaging system was installed in cash machines both by NCR Corps and by Diebold Corp in successful public trials in several countries after 1997. In 2006, ICAO internationally standardized iris scanning as one of the three biometric identification technologies for use in e-passport. Let's take a look at how it all works. The unique iris pattern must be recognized to pass such a biometric scan, allowing an identification response. This means that there are two stages in the scanning of iris. The stage 1 is talking about taking a snapshot of your eye, and stage 2 is confirmation of the authenticity of the eye. Let's see what happens in stage 1. All that a recognition system needs to verify a person is a snapshot of their iris. Therefore, to launch this scenario, each person must go through one-time photographing of their eyes. In this case, The photographing procedure takes place under standard lighting and invisible infrared lighting. The latter is a type of light used in night vision devices that has a slightly longer wavelength than ordinary red light. Infrared light in the iris scan helps recognize the unique pattern of darker eyes more accurately, which is more challenging to do in normal light. These two digital photographs, taken under different types of lighting, are then subjected to computer analysis, which removes unnecessary details such as eyelashes and highlights about 240 features in iris patterns, which is approximately 5 times more than in fingerprint identification systems. After that, all found unique characteristics for each eye are converted into a simple digital number consisting of 512 digits, which is also called an iris code, which are stored in the computer database along with your name and other details. Taking a picture of your eye is completely automatic and does not take more than a few minutes. In stage 2, once the iris photo has been entered into the database, your identification process will be easy and hassle-free. The person stands in front of an iris scanner connected to the database and goes through a quick rephotographing of the eye. The system quickly analyzes the resulting image, extracting an iris code from it. It starts the procedure for comparing hundreds, thousands, or even millions of iris codes available in the database. If the code matches one of the codes entered in the database, the person is positively identified. If it fails, this means that the snapshot is not familiar to the system or the person is merely trying to counterfeit who they are. This is a simple block diagram of a system for automated iris scanning. The pupil and iris are first detected with the help of an operator, after which the image is acquired. Image acquisition is a process which deals with the capturing of high-quality image of iris with the help of a digital camera. It is desired to acquire images of the iris with sufficient resolution and sharpness to support recognition. It is important to have good contrast in the interior iris pattern without any distraction in the image. Iris localization is the process that delimits the iris from the rest of the acquired image. After the camera situates the eye, it narrows in from the right and left of the iris to locate its outer edge. It simultaneously locates the inner edge of the iris. The image is then converted into a 512-digit number, also called the iris code, which is compared with previously generated iris codes in the database. This process is called pattern matching. There are many advantages of using iris recognition as a form of biometric authentication. Speed and accuracy. Once enrolled, iris recognition is one of the fastest biometric matching modalities on the market, with the ability to handle very large populations with speed. It is also one of the most accurate, with one of the lowest rates of false acceptance and false rejection rates. Stability. A unique iris pattern is formed at the age of 10 months and remains unchanged throughout life. The iris doesn't degrade with age as well. It is protected by the eyelid, cornea, and aqueous humor, making changes as a result of injury much less common than other modalities. Uniqueness. The probability that two different irises will have the same pattern is practically zero. Flexibility. The technology can be used both independently and in conjunction with other security systems. Reliability. The iris pattern cannot be lost, stolen, or counterfeited. Non-contact. Iris recognition doesn't require physical contact with the sensor for scanning, making it more hygienic and less intrusive than fingerprints and other touch biometrics. Although iris recognition is one of the most accurate forms of biometric identification, there are some disadvantages to it. Higher initial costs. This technology's cost is more compared to other biometric recognition systems like fingerprint sensors. Mass tracking and bulk collection. Governments can use this technology for mass surveillance and tracking. It can be hacked. Some commercial iris scanners can be bypassed by using high resolution images of a user's iris. To take the scan, a person must be present at the spot. Accuracy of iris scanning can be impacted by the capture quality, including movement on the part of the individual, reflection, particularly with glasses and contact lenses, and distance to the individual. All of these can be overcome, but they are a factor when making your biometric modality choices. Being the most accurate form of biometric authentication, iris recognition is generally used in cases where high security is involved. A few major applications are listed as follows. It is used in ATMs for cash withdrawal, tracking criminals and their records, logging into personal devices and appliances, tracking missing or wanted people, and accessing important or confidential information. Iris scanning is often confused with retinal scanning, so it is important to know the difference between the two. While the iris is the colored part of the eye which surrounds the pupil, the human retina is the thinnest tissue in the body and is made up of nerve cells located at the back of the eye. Due to the complex arrangement of the capillaries that feed the retina with blood, each person's retina is unique. Similar to irises, retina differs in identical twins due to the complex network of blood vessels. The retinal pattern may change due to diseases such as diabetes or glaucoma. However, in other cases, the retina, as a rule, remains unchanged from the moment of birth until death. While iris recognition captures the iris's texture pattern, a retina scanner captures an image of the network of blood vessels inside the eye. Iris scan can be taken from a normal distance, around 1 meter, while you need to be close to the device for a retina scan. The process of iris scanning is easier than the process of retina scan. Iris scan is widely accepted, while retina scan is not. Iris recognition remains one of the most promising biometric technologies for personal recognition. Especially in demand is the realization of the iris's potential for use in non-contact scenarios. Identification and a face image, and possibly other contactless biometric identifiers. Eye scan recognition has certain advantages over other biometric technologies that make this technology one of the most preferred mobile devices. In recent years, several companies have introduced smartphones equipped with iris technology for authentication or identification purposes. Biometric authentication is a promising technology that will eliminate the usual authentication schemes using a password. This will increase the convenience of working with the device and at the same time increase the level of protection of personal data. These are some of the references. I hope you like this video and thank you for watching. Any comments and suggestions are welcome.